Hello everyone, this is Mikhail from Coherent Gameface, and this is part 2 of our racing game UI series. In this video we're going to go over how to create a gauge and display the rotations per minute of the engine, the speed, the gears, and as a little bonus we'll also be creating a counter that will time all our laps, count them, get our best lap and our last lap. And alright, let's get into our code. So we have this gauge that I've already designed in Figma, where we have a rotations per minute bar that has this dashed look. We also have a speedometer that shows the miles per hour and gears. And the bars on the bottom of the gears will light up according to our gear. So we'll first create our gauge, and let's put inside. Let's not put anything inside for now. Let's set the style for it. So in our style sheet we add the gauge class selector, set the width to, let's say, 30 VH and the height to 25. The position should be absolute, and we need to position it in the, not top, but the bottom. So set the bottom, it should be bottom, no, sorry, not top, right, so the bottom right. And let's save. On second thought though, let's add a little bit more spacing to the edge of the screen. So let's set the bottom to be 2% and the right to be 5%. Yeah, this should give us a little bit more space to work with. And we can go back to our Figma file and let's export the design but without the bars. So I've already grouped the bars in a group that's called don't export. So we'll go select our gauge now, and to the right there's an export option, and we'll set the exported file to be twice the size of the one we have in Figma, and export as a PNG image to preserve transparency. Alright, so let's save it. And we need to get to the folder where we saved it. Here. Okay, copy it and go to our project folder and paste it in the assets folder. Great. So now we can add our background image and set the URL to be to the gauge. Let's just put with a capital letter just in case. And we need to set the background size to be contain, the background repeat to be no repeat since it's repeat by default, the background position to be centered, and let's also center. Okay, let's first see it. It works, so I think this looks good enough for now. We can always change it later. Alright, so let's center of the items inside just in case. Align items and justify content. Great. And let's also add the font family to be contracts, the one we've added in the previous video, so we don't have to set for the different things we have. Alright, so nothing changes, which is expected. Great. Now let's start by adding things to our gauge, and we'll start with the rotations per minute. And since it's a dashed line in a specific, we can go back to our Figma design and show the things we didn't export. And here we have the tachometer bar and mask. So we can right click on our mask and use copy paste as SVG. So now that we have it as an SVG, we can paste it directly in our HTML. Okay. Something. Oh, yeah. I have to release the mask before I can copy it. Yeah, forgot. Sorry. So now we can copy it as an SVG. Yeah, you can see the bar you've shown. So let's copy it. And now we have our SVG element. So if we open it, yeah, we'll see that it doesn't really match because the width and height are different. So let's put 100%. And let's set the RPM width and height to be 50% and height to be again 50%. And we'll see it working, being positioned. Now, I've already done this once, so I know the exact values, but just in case we weren't sure, let's set it to 100% and I'll show you how to use the developer tools that you can do by either typing localhost 9444 or pressing F11 in your player. This works exactly like the Chrome DevTools, so we can select our element and now we can edit the height and it will change in our UI. So we can see here that 50% is okay, and if we get the width down, we can see 50% again is okay. So now that we have seen this, we can go and for sure say that 50% will work for us. Okay. So let's add a stroke opacity to our, and let's put 0.5. And we're going to use this as a background for our bar. So when the bar is not red, it will show this slightly transparent color. And to create our bar, we'll just copy to create this red bar, we'll just copy our previous path and change the stroke to the one we get from the Figma colors. We'll remove the opacity and let's also remove the dash array. And let's add a class so we can add stroke dash offset to it. And yeah, here we have our red bar. So now let's export the mask. We'll do the same again, export it twice the size. Get it to where we have exported and paste it in our assets folder. And now we can add to our RPM a mask image, which will be our mask. But it's called tachometer mask, yeah. And let's the mask size to be 100% by 100%. You need to make sure it stretches, and the mask position to be centered. And now we can see our bar being dashed as well. So let's get our RPM bar, and let's set the door stroke dash array to be, let's say, at 500, and the stroke dash offset to be 500 as well. So in theory, if we open it, it will hide the bar. Yeah, let's remove this stroke dash array because it kind of messes with our background. You see it's much better now. And let's set to our RPM bar. Let's check what dash offset we need to make it fill, because if we go from 500 to 0, you can see how it feels from the right to the left, and we actually want from the left to the right. So we go over the 500, and should be some, or negative, to work in both cases, but let's go with over 500. So we make our stroke dash offset to be let's say 554. Let's round it to 550, and so we can go from 550 to 1000 to fill our bar. And so we're done with our tachometer. So let's add our speed, and here it's pretty simple. We'll just add the speed itself and the miles per hour tag, and let's create a speed element, and let's just put like a random number inside, and we'll create another div with miles per hour. We've created a second div because if we at some point need to change it to, let's say, something like kilometers per hour, we can easily do that if we have a separate element. So now we'll add our speedometer selector. We'll set its position to be absolute, so we can put the different on top of each other, and let's enter everything inside, but we need to set the flex direction to column since we want to be above each other, not next to each other. And let's set the color of the text to be white. So if we open it, we'll see it being in the center, but we need to make the font size a little bit bigger. So let's add our speedometer. Let's speed text actually, and let's set the font size to be 3 rem. Let's see how it works with that one. And I think this is okay, but in the design we can see that the text is a little bit not off-centered. So let's add a transform, translate, and move it, let's say 1 VH to the top. Okay, so that's better. And last, we need to add our gears. So we'll start by let's add the HTML for it. So we have the gears text. We'll just say gear, and we'll add the gear itself. And yeah, okay, this is a little bit confusing, but I've just copied the gears bars that were at the bottom. Yep, and since the gears bars and the tachometer are not positioned absolutely, we can see it pushing each other to the side. And again, let's set the width and height to 50%, just like we did with the tachometer. And let's enter everything inside. Yeah, we can see that it's not that, so we can, let's add a transform and let's move it positive to VH. And it's not exactly. So let's open our DevTools again. Let's select our gears and let's move it. Yeah, I think 2VH is actually good, but we probably need to move it on the x-axis as well. So let's change this to be on VH, and let's get it down to be like 0.6. Now we just need to fine tune. We also fine tune the width and the height. We won't need the X translate. So let's set this to 160. And if we refresh, we have it working as expected. Okay. Let's add our gears text. So we have the gear and the text is just say gear. So let's put our gears and let's say it's gears text. Let's add the same as with the speedometer. Let's set the position to be absolute. Let's set the color to be an opaque white, and again let's center everything. And everything should be in a column as well, yeah. And let's set the font size to be a little bit bigger. And again, let's move it a little bit to the bottom. Let's add a gear so we can see how it will look. Yeah, I think this is good. So let's add the gear actually, to have a font size of, yeah, let's say 2 rem, and the color should be the red from our bar. Let's see, and yeah, I think it looks good. Or let's make it a little bit bigger. Yeah, let's make the font a little bit bigger. Okay. Alright, so now we have everything styled and added. I'm going to show you how you can bind the data from the game to your UI. And we use the data binding attribute. There are different ones. So here we're going to use data bind value. Actually, it's data bind, not data binding. My mistake. So what you need to do is create a model in your backend, and you put this model name using double curly brackets. And this model is like an object that you can access properties of. So we have the speed here. And let's say the gear. We will create these models later, but for now let's just set the names so that we know what we should be doing. Now for our bar we can set the value, but we can do data bind and style and access the style properties. So all CSS properties will work, and now we can add data bind style, stroke dash offset, and bind it to, let's say, yeah, the RPM. And yep. And let's set the gear bars on the bottom. Let's add a class called gear selected. So when a gear is selected, it will just cover the bar to be red. Let's set the stroke opacity to be 1 since it's 0.5. And now we can use data bind, but this time will be class toggle, which will toggle class based on a boolean value, and it's written like first add the class you want to toggle, so this will be gear selected, then our expression. So this should be player car gear, and let's make it equal to R. So this, if the car is in reverse, this bar will become red, and we can now copy this, and let's say it for the rest. So this should be 1, 2, yeah, sorry, it should have been 2, 4, and lastly 5. So we've done like this because our car just have 5 gears on our track, but you can change it and do it however you want for your UI. And now that we have our data binding caret, let's do the same thing we did with the events, and let's mock it in our JavaScript. So we'll do this by using engine create.js model. We'll write our model name, and as a second attribute we'll add the model itself. So if we add RPM to be, let's say, 1000, let's add the gear to be reverse, and the speed to be, let's say, 90. So next we need to use engine synchronize models so that the data binding gets synchronized with the models. This will synchronize all of our models. We can have more than one. And now if we refresh, we'll see the bar is filled, the gear is reverse, the speed is 90, and the first bar of the gears is red now. So this is perfect. Now we can remove this from our JavaScript, and we can hop on into Unreal to start creating. First thing we need to do is register our models, so let's do it in the ready for bindings after our countdown. And let's get our Gameface HUD and use create data model from struct. And now let's call it player car, and for our struct we need to create a blueprint structure. To do this, we'll go to our content drawer, right click and add blueprints structure, and let's call it player car struct. Now that we've created, we'll just double click on it, and here we have all of the object properties that will bind to our UI. So let's create the first one, which will be called, let's call it speed, should be speed, and let's change it from a boolean to be an integer. The second one will be RPM, and yeah, we didn't change the first. Okay, so we'll change to integer, and let's add the last one, which will be our gear, and this one is a string. Great. So now we'll save our struct, and inside our level blueprint we'll add a new variable. We'll call it player car, and let's add the player car struct. And let's get it. So now we have a data model that has the player car struct, and it will bind to our. Now, since we're going to change it almost on every tick, let's get our Gameface HUD again. And we need to set the members. So first we need to set the members in our struct. So it should be set members in player car struct. Yep. And we can get our struct reference. And no. Just a second. Yeah, we need to set the members. Sorry, kind of forgot how this works. So we need to set the members. We need to get the struct. And now that we have gotten our struct, we can actually select the pins that we want to update. Great. Now let's set the speed to 90, rotation per minute to 1000, and the gear to be reversed. And now we can use our branch, because before we start synchronizing our models, we need to check if they're ready for bindings. Is triggered. We need to do this because our game will start crashing if we try to synchronize the model when the bindings are not ready. So if they're ready, we're going to say yeah, we need the HUD, and let's say update whole data model from struct. Select our struct, and let's synchronize our models. This is the exact thing we did in the JavaScript. So every time we need to change something in our model, we'll update the model and then synchronize it. So if we play our game now, we can see at the bottom right that everything is set correctly. So now let's set them with the correct ones. But first, let's show if we change them that it will again work. Great. Alright, so we use this guess to vehicle to get all the data we need. So let's create some functions that will call get speed, set. Actually, we have these variables first. Yeah, sorry, I'm kind of jumping around here. that have our gears, our RPM and our speed. And let's create some functions to set these variables. So let's call this one set speed, and let's input the speed that we get from our car. And the reason that we are setting our speed is because first we need to truncate it so we can get an integer, since it will be a float. And let's make it absolute, since if we reverse the car it will show the speed but in negative, and we just want to show the speed, so we don't really care if it's positive or negative here. And right now in our level blueprint, let's set the speed, and from our vehicle movement component we can get let's move it since there will be a little bit more, and let's get our speed. In miles per hour, and pass it to our function, and this will set our variable. So we can create another one, and let's call it set RPM. And something here we have to remember is that the RPM bar works from 550 to 1000. So we'll set the RPM and the max RPM, and we can get the current rotations per minute as a percent of the max rotations per minute. So we just need to divide the rotations per minute to the max rotations per minute, and the percent that we get, we'll just multiply it to actually no, yeah, we should multiply it, not add it, to 450. Okay, so let's multiply to 550 and add it to 450, so we can get, yeah, the math is a little bit confusing, but again I'm just showing you how you can demonstrate. Now the reason that we're doing all of this math inside our game is because we should avoid doing anything like this in our front end to get the most optimal performance. So any calculations and such that can be done in the backend should be done in the backend. Now we get our max rotation speed and the current rotation speed. And get our function, and let's pass our nodes. And last, let's set the gears. Now the gears are not in the way we want to display them, since they will be from -1, which will be the reverse, 0, which will be neutral, and so on. So we need to check first if the gear that we have is greater than 0. If it is, we'll just set it like that. But if it's 0 or -1, again, let's make another branch and check which one is it. So let's check if it's equal. Second. Yeah, so let's check if it's equal to 0. And if it is, let's set our gear. No, we can. Sorry, I'm really not that used to Unreal blueprints. I'm just showing you how to create it. So yeah, let's set our gear, and if it's 0, let's set it to be N for neutral. And if it's no, we need to set it. It should be reversed. So now we have this done, we can go back to our graph, get our set gear function, and connect it to the set struct. And let's get the gear. And should be everything. If we compile, save, and now if we run our game, we can see it's 0, the gear is neutral, and if we start, we can see our bar start to fill up, our miles per hour to change, and the gears to shift upwards. And if we press reverse, we see the gear getting reverse, and we can see the miles per hour are positive and not negative. So perfect. And as a little bonus, we'll also be showing how to create a timer. And this, we hear not how the timer is created, but more like how you can create a 3D effect for the timer. The timer is simple. We do have 4 categories, which will be laps, race time, best time, and last lap time. And we'll just create a timer container for each one. let's call our header, which will be our text, our label to say, and timer value. And we'll copy it for each one. So let's call it that lapse should be 0. That race time. And let's put it in the minutes, seconds format. Yeah, let's use best time, which will be the same. And these are the default values. This will definitely change, but we're going to use them to check how it looks when we preview our UI. And we can see it in the top left. Now let's change it. Just mark what we're going to use for the lapse here. And let's get lap timer. Set position to be absolute. Set should be in the top right, so this time the top will be 2% and the right will be 5%. And yeah, you can see it moving where we want it. Let's set the color to be white. And let's give it a width of 40 VH, so that the changing size actually of the timer won't interfere with our layout. And let's add a text transform, uppercase, so that all of our text will be like this, and add it to be the contracts font that we've added previously. And yep, we can now see it, but everything is aligned to the left of our container. So let's say get our timer container and add display flex, and flex direction should be column since we want to be on top of each other. And now let's align the items, but this time instead of the center as we usually do, let's add flex end. So flex end should be our right. And yeah, we can see our text line to the right. And let's add a bit of a margin so that we'll separate them. And I think this is good. So let's change the font size and let's give it a background of and some padding to create some space for our text. And okay, perfect. Let's just separate them a little bit more. Okay, I think this is good. Okay. I'm just testing out to see what will look the best here. Again, this is for personal preference. Now we can to our timer content, actually timer value, and set the font size to be 2 rem. I think this is good. Let's give a little bit of padding to our, yeah, okay. Let's add a large text class to our labs and our race time, just because I want the font size of those to be a little bit bigger than the rest. And so font size will be like 4 rem, twice the size of the other one. I think this is good. Yeah, let's add less padding so that, okay. And let's rotate it into perspective. So to do that, we add to our body the perspective property with perspective origin center, and this means our perspective will be 1000 pixels to the computer and to screen, sorry. And let's do a slight rotation on the y-axis. It should be negative though. We want to rotate in the other direction. Okay. And let's just move it a little bit to the bottom so it doesn't touch the top of the screen as much. And now we can data bind this as well. So let's use the same model. We'll play a car, and this will be laps. Now let's get the main value. Again, player car, and let's call it current time. And let's just copy this and paste it. To the other ones. And now here, instead of current time, it should be best time and last time. And again, nothing will change. So now back into Unreal Engine, we can use this function that says we have this function that says the timer. We use the event ticks to do this, and we have a checkpoint that's set at the start line, where every time we pass it, we will count our laps, and when we pass it, we'll set the last seconds of the lap, we'll increase the lap, and then we'll check if the current time is less than the last time, and we set it as the best. So now in our struct, we need to add the other properties, no variables. that we need. So we have laps, okay, let's at the current time, and let's call it, let's add as a string. Okay, so we can add best time, and last time. Okay. When we save, we select our struct, and when we select our struct, we can set the pins from the right. Great. Now we've already added our variables, so we're just going to get them. I have made already a macro which will format our time, so we'll just get the minutes and the seconds from it and put it in a string. Again, like I've previously said, it's better to do this inside your engine instead of in the JavaScript, as it will be more performant. So let's pass each string, each time through the macro, and everything else should be exactly the same. So now if we start our game, we can see to the top right everything will be 0 and the race time will start. So let me show you what happens when you get to the end. You just cut this part a little bit short, don't watch me drive around the track. And now when we pass the starting line, we can see the laps go up, the timer restarts, and the best and last time. And this is everything for this video. In the next one, we'll be showing you how to create a mini-map in your game that will have the car as a marker, we will follow the racetrack as a path, and have all the other cars appear as markers as well on the minimap. If you've liked this video and the rest of our tutorials, leave a like on the video and please subscribe to our channel. We are planning on creating more tutorials and other interesting videos, so if you have any ideas or suggestions, feel free to leave a comment. And that's everything for today. Have a nice day.